Hi everyone, my name is Arturo Won from the Lithium Grid. In today's video, I'm excited to take you behind the scenes of these renders. We'll start by showing you how to set up a custom rig for any car inside Cinema 4D using constraints and Xpresso. Throughout this tutorial series, you'll learn the basics of Xpresso and rigging, and you'll also discover how to use the new Cinema 4D car rig preset to streamline your workflow. Let's dive in and get started. So now that we have our hierarchy already set up, all our controllers already created, already constrained to their boundaries, everything is set up for us to start with Xpresso. Let's go ahead to our final scene and see what is left to do. We have all these controllers, we just need to connect them to start animating. And one last thing that before we go to Xpresso that I want to do is I want to create more controllers and the user data side of this master control to create these parameters that will essentially control the rotation of the tires as a master control and individual ones. Okay, so let's go ahead and create these controls and move to Xpresso right after. Now in my scene, the way to do so, it will be to go to here while selecting the control that you want to add this new user data. We'll go to user data, I'm going to go to manage user data, and I'm going to create a group. Okay. I'm going to call it wheel capos. Okay, and if I press OK, first of all, nothing will happen because this group is empty, but if I were to add any data to it, you'll see that a new tab has been created. Now it doesn't say wheels, it says wheels here at the bottom, but in this case I want to make sure that wheels is here at the top so that animator knows what to look for. So if I go back to my manage user data window here and click and drag this wheels group out of the user data group and I press OK, you will see how now it has become its own tab. Okay, so let's go ahead and modify this data. I'm gonna first of all rename it with wheels main. This will not be a percentage, but instead a degree with no limits. I'm gonna press OK, and now we have this parameter. I like to keep it organized, so I'm gonna create another group, get underneath, and call these maybe just main. I'm gonna control and drag right underneath of it so it's not outside the groups of wheels. And I'm gonna rename this main to single. Okay, and here I'm gonna separate this wheels main to wheels front only. Enter. I'm gonna copy this parameter and I'm gonna set it to R for rare, and I'm gonna press OK. So now we have all the parameters that we need. Last thing I want to do is just to keep this visually more interesting for me, or organized I guess it will say, is I will change this group from one column to two, meaning it's going to split this in two, so this parameter will go right here, right next to it, like so. And at this point we should be ready to go and start with Xpresso. I want to right click on the name that I'm going to create an Xpresso tag onto. Come here to programming, Xpresso, and I'm going to dock this window right here on the side by clicking on these three lines and drop it right in there. That way I can see it side by side. Now we can drag our control to the Xpresso window. It will create our first node, and I'm going to click and drag each parameter to their corresponding input for the blue or output if they're going to be the ones driving something. You can also access these parameters by coming here and looking for them. But I like this method where you can just click and drag the options or the parameters that you're gonna need. I'm gonna come here to the corner and make this bigger. Okay. And for now, I'm gonna hide this main body. I'm gonna make sure everything is turned off. I only want to see the wheels here. In previous videos, we talked about the importance of organizing this hierarchy and isolating parameters so that it can be easier for us later on to connect them. And now we're gonna see why these are gonna come into place. Because if I were to animate this parameter, the bank, you can see how this is the only parameter that I need to animate or control in order for me to achieve the desired result. So while having them all selected, all these tires, I'm gonna click and drag them all into my Xpresso window. Now organize them real quick. And like we were looking at before, we're only gonna be bringing this bank axis. But now instead of dropping them into the red side of it, we're gonna drop them into the blue, which is the input. And we're gonna do that for each of them. If we were to directly connect one of these outputs to the inputs of the input of the tire, go back to my main control, go to the wheels tab, and see what's going on with this tire. We can see that indeed it is controlling it, and it seems to be working fine. That is great. That's what we want. And for visual purposes, I'm gonna keep all my rear tires on the back, so we're facing left. I'm gonna try to mimic this sort of layout. Okay. I'm gonna make this connection to this other tire right here, and I'm gonna come in here and test to see if this is working. And yes, it is working. If I isolate just to this tire, just to make sure that I got the right one, it seems to be the right one, so we're good to go. Now, what I want to do with this setup here is I want to add the value from the main controller, the main wheels controller, to each of these individual ones. Let me demonstrate. I'm gonna come here to my search bar. I'm gonna look for a node called math. And I'm gonna connect this main output to our first input of our math, and the function that we're gonna be using is gonna be add. So just as default, I'm gonna connect the for wheel to, and I'm gonna reconnect my front left tire. Going back to my controller, let's see what this is gonna do. If I were to animate the main, this is gonna activate all the wheels. But if I wanna control just the front wheel, this will do so. Okay. Hold down Control, click and drag this node. And we're gonna do the exact same thing for the other wheel. And we're gonna go test. We see our first discrepancy here. So what's happening is that the rotation right now, it's inverted. It could be because the axis is rotated or something else, but we can address that here in Xpresso. Let's give us more space. One of my favorite nodes here in Xpresso, it's called Range Mapper. This node you're gonna see it yourself using it more often than not. It's super powerful. And in this case, all I want to do is change the output, and instead of going to a positive value, it's going to go to a negative value, meaning just reverting the effect. And we can test how they both are going forward. Both going forward, and if I isolate it, they both are doing the same. Perfect. And we're going to do the same thing for the ones on the back. Let's go ahead and connect them. Okay. Copy this. To the bottom. Main wheels on the top. This is just to keep it visually consistent with the other math notes. And I'm gonna go ahead and connect this to my rear tire. It is a good practice to, every time you make these connections, to go ahead and test them, just to make sure that what you're doing is the right thing. It seems to be working fine. All we need to do is work on this last one. And now we can test again. All the wheels are moving forward, rear wheels by themselves isolated, and the front ones as well. Perfect. We have finished our connection for all our rotations. So we're gonna move this up a little bit, and I'm gonna bring, on the next part we're gonna be talking about steering. So let's go ahead and do that. We're gonna do this connection. You guys can see that the tires are rotating as well as the steering wheel. So I'm gonna go into my main group here, look for the steering wheel group, holding Alt. I'm gonna click once. That's gonna override the visibility, which is also the same as making sure that these parameters are on instead of default, which is no lights, and off it's when it's red. Okay. Now, an extra tip here is that when you have multiple groups open like that and you want to close them all, but when you open them, you don't want to see them all open again because it's a whole mess. If you were to hold down Control, this will ensure that all folders, even subfolders, will be all collapsed, making it more neat and organized and easier to access as well. So, like in the beginning, we're gonna select the main control, or the control that we're gonna use. Drag. It's gonna be our driver. We're gonna go back to this group. And once again, this is why we were talking earlier about why is it important to make sure that your pivot point is when you need it to be. And we also talk about how to create nulls inside that specific null that you had, so that instead of animating all these parameters, we can just isolate it by animating just one. In this case, this is the only parameter that we need to animate, which is the pitch. So what we're gonna do is that since this is the object that will be control, we're gonna drag it in place. Once again, I'm gonna make sure which is the right axis, and we're gonna click on that axis. In this case is this pitch. Bring it into the blue side, which is the input. For my steering, we know that it's only moving on the Z axis, so that's the only parameter that we're gonna bring into the red part here, which is the output. And the first thing that I want to do is to once again bring in a range mapper. And do the connection directly. Inside the range mapper, we're gonna see more options than the ones that we were playing with before. In this case, now we're gonna be worrying about this part, the output range and the input range, and the type of data that we're gonna be utilizing. In this case, this input for the controller which will be a real type of data, not a degree, not a radian. It should stay as it is, but for the wheel, since it's going to be rotating, we're going to change that to degrees, and we're going to test it. As we can see, it's going very, very fast. Now, one of the things that I like to do when using controllers like this that have limits is here inside Xpresso, there's a very useful node called result. I'm going to bring this result here. I'm going to plug the output of my controller into my result just to see what is the real value here. Because inside of Viewport, we're using centimeters, right? Inside here, I believe they're using units, therefore some specific type of unit, but therefore the values are different. As you can see, if I go all the way to the end, my max number, or in this case, my input upper will be 59.055. Therefore, my input lower will be the negative. Okay. And this doesn't need to be like that either. It could also stay at 0 as long as this value also obeys the same rule. Okay. And sometimes it's easier to leave it like that. For this part, I want to just show you what this is going to do as it is right now. So first of all, from the middle, still going to the opposite direction, which is easy to fix. This is just a matter of adding a negative sign here, and that will fix the rotation. And the other part of it is to like maybe decrease the amount of degrees that this value will interpret. So the way that I like to think about it is that if this control goes all the way to its maximum value, which is here, this is the limit, what will be the degrees that I want to see on this wheel? So I can click and drag and just do exactly that. Let's see. Obviously, you can have videos and have more reference of like exactly how much a wheel will turn, but for my purposes, this is more than okay. Okay, so with this, I have successfully connected my steering wheel. Okay, moving on to the tires. Once again, I want to emphasize the importance of us taking that moment to prepare these things before we even start making these connections. Now, because we have separated this into groups, now we can look for the specific axis that we're going to need to control. In this case, it will be the pitch for this tire and the heading for this other. So I'm going to click select the other. Otherwise, it will, if I were to hold down shift, it will select everything in between. I'm just going to select the first one, select the second tire. I'm going to make sure this is the pitch. This was the heading. I'm going to duplicate this wrench mapper, control drag, make our first connection, and go ahead and connect them. See what happens. The axis seems to be wrong, but the rotation seems to be fine. So right now, I just want to identify which one is obeying the right rules, right? If I go to the left, this seems to be fine. This one seems to be going into the opposite direction. So let's go ahead and change that. While going all the way to my input upper, I'm going to identify which wheel is this, FTLT, which is this guy. And what I'm going to do is I'm going to create another math node. I'm going to make the first connection here in the first input. And I'm going to change the function to multiply, and I'm just going to multiply it by 1 so that it goes to the opposite side. And we're going to test this one more time. And there we go. Now, I'm going to unhide my car for a little bit. And I'm going to see that here, for instance, I'm starting to have geopenetration. The beauty of this range mapper is that you can go in there and click and drag the value from the upper max, since that's exactly where we are. We are on the very top. So when it's all the way to the right, what should be the value that you want to see on this tire? Like I said, that's how I like to see it. So for me, it seems to be somewhere around -5. And if I go to the opposite side, it will do the exact same thing. And we can test it. So if we go here to the tire, we can see that on the opposite side, sorry, here, it is set at 35 degrees, same as for the other tire. Okay. So now we have the steering in place. Okay. Lastly, for Xpresso, we're going to set up this weight control. Click and drag the control and bring it into Xpresso. In this case, we're only going to be moving this control. So all we need is to bring these parameters individually, not bringing the P, because P will bring the entire position as like so, meaning this will be a vector file and you will no longer have access to individual axes. So I'm going to bring each of them individually like so. And from our first video, when we were talking about pivot points, once again, this was set right here to the middle of the car, right at the bottom, so that we can control this rotation and also the y-axis. So now we are working on this control. Okay, so let's go back to our scene here. This is the group that we're going to be controlling. We're going to bring them in. We're only going to be focusing on the input side. So first things first, we're going to bring the position on the y-axis. We're also going to identify which axis for the rotation is that we need, and we're going to need the pitch. Whoops. We're also going to need the bank. Okay. I'm going to move this position up to the top. For the position Y will be exactly the same. So if I move up and down, it will be the same thing for our driven object. And now for the other two parameters, since we're going to be working or translating positional data into degrees, we're going to bring our range mapper. I'm also going to bring a result node, and we're going to see what we're working with. So we're going to, first of all, alt 0 to zero that out, our main control. I'm going to bring our x-axis, since it's the first one that we're going to be working with, all the way to its input upper, or its maximum positive value. And in this case, it seems to be that its maximum value is 39.37. So we're going to do that right here. Its maximum value will be 39.37. Enter. And once again, we're going to change the output range to degrees. We're going to make sure, I believe it was pitch. Nope, that's not the axis that I wanted. It was the bank. And there we go. Now it's definitely too strong. So we're going to go all the way to the front, or to the max value here. And I'm going to do something minimal, something like 2 Okay, so if I move back and forth, seems to be fine to me. Perfect. Zero that out, Alt 0. And now we're gonna be working on the z-axis. Once again, we're gonna bring it all the way to the edge. Now, since we make this a perfect square, that means that this value for the input upper will be the exact same thing for z. I'm gonna click and drag this parameter and put it on top just to keep it visually organized. I'm gonna connect this two, and I'm gonna see what's going on. Seems to be going the opposite direction, so that's easy to fix. All we need to do is add a negative to the front, and maybe here we can exaggerate this a little bit more to -3 or 4. 4 might be too much. I think 3 is fine. Yay. There we go. Now we have all of our controls here set up. Go here, making sure that everything is working. Okay. And for the last control that we need to make a connection with, it will be this drift control. Let me bring this quick simple scene that I just created for you guys. I'm going to be uploading this, so please check the link in the description. It's just to showcase some of my favorite constraints. First of all, let's bring the constraint tab or window out of here. So I'm going to go here and dock it. In my window, you will see that here is our constraints. All you need to do is click on them, and it will ask you what type of constraint you want to utilize. You have transform constraints, parent constraints, app constraints, etc. You can always right click on them, go to show help. It will take you to Cinema's help page where you can see all the documentation in case you need to go over any specific parameters. But for this first example, this is a parent constraint, as you can see. Is acting like a parent where it's activated at this point and then it gets deactivated. That's how I'm controlling that. I'm also using a transform constraint to take control over this box. That's why it can move freely, but it's obeying this main control. In our other example here, we have a clamp constraint, which is this. The target will be the object that will be utilized as the target for this constraint. In this case, is the spine. I've used this combo multiple times for infographics, especially when you have 3D data tracking. It's very useful. I like it a lot. And the last one that I think is very useful is the surface constraint. Basically, that's what it says it does. It constrains an object's position to the surface of another object, giving you the freedom to move around, but the object will move depending on the deformation of the normals of the mesh that you decide to apply the constraint onto. All these three examples will be saved into one file, which I will be uploading for you guys to take a look if you guys want to dive into this and dissect a little more. But having said that, all we're going to be using for this last part will be a simple parent constraint. And we're going to tell it to use the target as the control drift. And now it seems to be working. There is also transform constraint, which either or you could use. Now, if I were to create one simple scene here really quick, just to show you the difference between, I'm going to create here cube and a square. I'm going to move this away. I'm going to create the same thing and dock this to the side. Create a constraint, use a transform. Look what's going to happen to the cube. It's going to go back and snap to that position. And if I were to move this rectangle, which will turn out to be the controller, its coordinates, its transformation values will be the exact same thing as the values for the cube, no matter what you do. They're always going to be the same. Okay, keep that in mind for a second. If I were to change that transform to a parent constraint and do the exact same thing, similar behavior will happen. Whenever I move the control, the object that is with the constraint will follow, but the difference is now that the transform the values for its rotation and position are not longer going to be the same. Therefore, you can animate these values and offset them. Same as nesting an object under another object, and now you can animate these parameters if you need to. Okay, that's the only reason why I decided to go for a parent constraint instead of a transform constraint, just to have that extra freedom for animators to come and offset this if they need to, or have more flexibility when it comes to animation. And this will be the end for this part of rigging. At this point, you should have a fully rigged car. Additionally, I will be adding this into the link in the descriptions for you to have a reference. How did I animated this car? What parameters did I use, and how did I use this vibrant tag to add more sort of like dynamic effect to the car? Let me know in the comments what you think, and if you come up with any cool animations, please make sure to post it and tag me so that I can take a look at it. Looking forward to see what you guys are capable of doing with this simple rig. On the next video, we'll be talking about the new cinema for the car preset. We'll cover how to set it up, how to connect it to your car, set up the controllers, and get it going. Make sure to subscribe and stay tuned for more content. Thanks for watching, and I'll see you next time. Ciao!